Good morning, children. Welcome to the online classes of our Rajana School. I am your Jagadish Master. Children, please sit straight and close your eyes. We have a prayer. Hear your child now, O Lord, as I fold my hand in prayer. Bless my parents and teachers. Keep us on your love and care. Help me to be kind to others, happy in my study and play. Give me your strength to conquer any wrong that comes this day. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Okay, children, we are in chapter 2. Okay, that is motion. In today's online class, we will study about average velocity. Now, see, children, you know what is velocity. Velocity is nothing but having speed with a particular direction. See, some of the examples I am showing you, they are having speed. At the same time, there is a direction, particular direction, they are moving in the particular direction. So speed is equal, see here I am showing you the formula triangle of speed and velocity. Okay, that is velocity is equal to displacement by time. Here upon velocity you are observing a red color arrow mark. That is nothing, that indicates you that it has certain direction or a particular direction. Okay, for both velocity and as well as a displacement. So that is why we say that velocity is a vector quantity. See here I am showing you an example. Okay, to calculate average velocity. A man rides his bike 90 km in 3 hours towards beach which is east from his house. Okay, see here a direction is given east. So displacement by time, that is 90 by 3 gives you 30 km per hour. Direction is east. Now see one more example, my dear children. Next he rides his bike 60 km back home which is west and stops for lunch after 2 hours. What is his average velocity? See, now he is asking to calculate average velocity. Distance, see here 60 kilometers by 2 hours. 60 is the displacement or distance which he traveled, 2 is the time. What is that? 30 kilometer per hour west, towards west, it is the average velocity. Okay, I hope you understood, my dear children. Now we will see uniform motion and non-uniform motion. So in this session, my dear children, we will see uniform motion, non-uniform motion and uniform circular motion. Okay, regarding uniform circular motion I will explain you by the end once again in deep. Okay, some more points we will cover there, but now we will see uniform motion. See, whenever a body is moving in a particular direction with a constant speed, okay, for with a constant speed, it is said to be in uniform motion. See, every time it is covering the same distance, every time the speed is same. That means, so when a body is moving with a constant speed or constant velocity, then we say that the body is in uniform motion. Okay, their direction doesn't change, at the same time speed also doesn't change. Okay, now whenever a ball or something falling from top to the, see here I am showing you basketball example. So in the first second it is 9.8 meter per second. In the second velocity speed is increased. Third second the speed is increased. That means it is for different time intervals, equal time intervals, its speed is changing. That means it is an example of non-uniform motion. That means for equal intervals of time speed changes, speed is not constant. You can observe many, everywhere the speed is non-uniform. I am showing you examples, my dear children. Okay, children, see here some of the examples I am showing you. Whenever a person jogging or a moving car, horse cart, merry-go. So in everywhere, my dear children, you will observe non-uniform motion. Okay. See here, for the graph for uniform motion, time distance graph it is. Okay, it is a straight line. What about the non-uniform motion graph? It is a curve. Okay, now my dear children, I hope you understood. Okay, now we will see uniform circular motion. So in order to define what is uniform circular motion, means the motion of a body on a circular path is uniform. Okay, that is speed is constant on a circular motion. In which motion? Uniform circular motion. Okay, whenever the speed is constant on a circular motion, we say uniform circular motion. Here the velocity changes because velocity, that is direction, is changing every time. So that is why we say in a uniform circular motion, velocity changes, so that acceleration changes. Okay, why velocity is changing? Velocity is changing means here not the magnitude, direction is changing. That is why we are saying in a uniform circular motion, velocity changes, speed is constant. Example, merry-go, an athlete running on the ground, and planets revolving around the sun. Everywhere it is a uniform circular motion. You can observe circular motion in these examples. My dear children, hope you all understood, but still we will study about this uniform circular motion at the end, because before going to know the study about uniform before going to study about uniform circular motion, you need to know about the terms acceleration. Okay, how acceleration happens, the best examples about acceleration, all these things you need to know before going into uniform circular motions. That is why we will study at the end. Meanwhile, we will recall what we learned now. So distance is the path or length traversed. Okay, displacement is the shortest distance in a specified direction. What is average speed? Average speed is the distance covered per unit, and average velocity is the displacement in a specified direction per unit time. Speed at an instant is the instantaneous speed, which gives the idea of how fast the position of body changes. Velocity is speed in specified direction. Okay, a body has acceleration when the velocity changes. Okay, now my dear children, the motion is said to be uniform accelerated motion. Okay, when the velocity is constant. Some equations of motion we will see, children. I am showing you here. V equal to u plus at, s equal to ut minus half at square, v square minus u square equal to 2as. What are these actually? These are the equations of motion. These are useful in solving problems, my dear children. Meanwhile, you just know the equations. Okay, I think you have understood what I taught till now. That is about uniform motion, non-uniform motion, uniform circular motion. Okay, now we will see acceleration. Okay, now my dear children, in order to study deep about the uniform circular motion, we need to know acceleration. See, whenever you are traveling in a car, suddenly a brake is applied. What happens? You will fall in front. Okay, you will move to the front side. Whenever it is turning right, what happens? So whenever car is turning to the right, you will fall to the left side. Similarly in a bus, bike, everywhere, that is velocity changes, acceleration exists. Okay now, velocity in the sense, velocity changing in the sense not regarding speed, but it is regarding direction. Okay now my dear children, see in the first example I am showing you, a car is moving at a constant speed, that is 80 km per hour. In the second, a plane is moving at a constant speed of 1000 km per hour. In which case do you think acceleration is involved? The answer is none, because they are moving with a constant speed, that is no change in the velocity regarding direction or else speed. Many people think that acceleration means high speed, but it is actually wrong. Acceleration exists only when there is a change in velocity. What is velocity? Both speed and direction. Okay, speed in a particular direction is nothing but velocity. See here, a body is moving from the initial point to 20 km per hour to a certain distance. What happens? Velocity changing. Okay, in the initial it is 0 km per hour, final 20 km per hour. See, with the same 30 km per hour velocity, it is continuously traveling and the direction is being changing. Is there acceleration? Yes, there is acceleration because direction is being changed. Okay, there is a change in direction, that means there is a change in velocity. So with a change, okay, direction is changing but the speed is constant, my dear children. So when the velocity is being changed, we can say that acceleration is existed. Okay, so my dear children, we will see how acceleration is calculated. Okay, acceleration is defined actually as the rate of change of velocity, that is acceleration equal to change in velocity by time. Initial velocity, that is u, and final velocity is defined indicated as v, time t. So acceleration equal to final velocity minus initial velocity by time. See here I am showing you the example. Okay, time is, it traveled for 5 seconds from A to B. Initially the velocity is 0 at the time of starting, but after 5 seconds it reached to a velocity of 10 meter per second, and the total time duration is 5 seconds. What is acceleration? Initial velocity final velocity minus initial velocity by time. So 10 minus 0 by 5 gives you 2. Okay, what about the units? So displacement velocity unit is meter per second and time unit is second. Okay, totally we will get 2 meter per second square. Meter per second by second gives you meter by second into second, that is meter per second square. I hope this division which I am showing you in green highlighted, you understood. Okay, that is acceleration equal to 2 meter per second square. So acceleration is a vector quantity, my dear children. Okay, acceleration and velocity has same direction. Remember all these points. Okay, children, we have types of acceleration, that is two types of acceleration: positive acceleration, negative acceleration, and also zero acceleration also we have. First we will see positive acceleration. Here bus starts from rest and velocity goes on increasing. So when velocity goes on increasing, acceleration changes, that is acceleration is positive. Why? Direction of velocity and the acceleration direction. So acceleration and velocity direction, acceleration and velocity are in same direction. Okay, they are both they both are in same direction, my dear children. Now whenever a apple or some fruit falling from a tree, so it is another example of positive acceleration. Here the whenever apple is falling down, the velocity is towards the ground. Similarly, acceleration is also towards the ground. That is, acceleration due to gravity acts on the fruit or apple. So that is why both velocity and as well as acceleration having same direction, that is downward direction. So that is why we say that it is a positive acceleration. Positive acceleration means nothing, my dear children, both velocity and acceleration are having same direction. Now we will see negative acceleration. What is negative acceleration? See here, whenever a car stops or applied a brakes, the velocity decreases. Whenever a bike or a car riding, we will apply brakes at the time velocity changes or decreases. Okay, negative acceleration, that is acceleration changes. That means so here acceleration and direction both are having different direction. Okay, my dear children, direction is acceleration is opposite to the direction of velocity. So then we say it is a negative acceleration. See here I am showing you some examples for negative acceleration. If I throw a ball to the upwards, what really happening? Acceleration is acting downwards. It is because acceleration due to gravity is acting on the ball. That is why to certain extent, after reaching certain height, it accelerates or it falls down, because acceleration due to gravity is acting. That is, acceleration is acting downwards and ball is moving upwards. That is why its velocity goes on decreasing when it is goes on decreasing when it is moving upwards. That means acceleration is downwards, velocity is upwards. Okay now, then we say that negative acceleration. Okay, why? Velocity direction is upward, acceleration direction is downward. Okay now, my dear children, now we will see zero acceleration. Okay, whenever a person riding a scooter or a car or something is moving with a constant velocity every time, there is no change in the direction, at the same time there is no change in the speed, then we can say acceleration is zero, because rate of change of velocity is zero. Okay now, hope you understood, my dear children, about types of acceleration, that is positive, negative and zero. Okay, now we will see, my dear children, uniform circular motion. In order to study that, once again we will study about velocity. What is velocity actually? Velocity is a description of both speed and direction. Nothing but speed having a particular direction. Velocity changes if speed changes or else direction changes. If any one is changing, definitely velocity changes. If both is changing, that is speed and direction, then also velocity changes. Okay children, till now we have seen what is velocity and how the velocity is being changed. So when any one, that is speed and direction changes, or else if both changes, it changes. Now take the example of a square, my dear children. See here I am showing you a square. Okay, so AB, that is the distance between A and B, is 50 meters, and the time taken to travel from A to B is 5 seconds. As it is a square, every side is same, that is every side is 50 meters. Okay, my dear children, see here what is velocity now, that is distance or displacement by 5. Okay, 50 by 5, you will get 10 meter per second. Now what is it actually? It is a speed. Now if you want to talk about velocity, so how we will represent it 10 meters per second along AB. Okay now, I am specifically mentioning the direction. Okay, 10 meters per second is the magnitude, and along AB, that means I am also saying about direction. I am mentioning the direction. So whenever I am mentioning speed with direction, it is velocity. Similarly, from B to C, 50 meters, time taken is also 5 seconds. What happens then? Velocity 10 meters per second along BC, that means 10 meters. Okay, it is the velocity from B to C. Okay, similarly from C to D, D to A, everywhere the velocity is same. But look here, when I am traveling from A to B, from B to C, the direction is being changed. Okay, I am taking the direction is being changed. That means velocity is changing, not about magnitude. Only direction is being changed. Similarly for hexagonal, what do you know what is hexagonal? That means, okay, having 6 faces, a polygon. So a polygon having 6 faces or 6 corners is nothing but hexagonal. So whenever a body is being traveling in hexagonal, we say the motion is accelerated motion. Accelerated in the sense velocity is changing, so acceleration exists. As acceleration is being present, we say accelerated motion. Now take the example of a circle in order to study uniform motion, uniform circular motion. See here, every time the direction is being changed, my dear children, it's every point. In a uniform circular motion, speed is constant, but the acceleration is present. Why? Direction is changing at every point. Here I am showing you through arrow marks, white color arrow marks. Okay, how the direction is being changed. So how the now every time the velocity is being changed, acceleration is present, so we say accelerated motion. Okay, whenever, not only in hexagonal, whenever the body is traveling in a circle also we say accelerated motion. Okay, now my dear children, see here, speed is constant, you know. Coming to the velocity, speed, in velocity there is speed and direction. Speed is constant. What about direction? Direction is being changed. Okay, not only we will see some of the examples for a circular motion. See here, I am showing you Earth revolving around the sun, planet's motion, planetary motion. Okay, it is an example of a circular motion. Okay, now one more thing I am showing you. See here, my dear children, a merry-go. Here also the speed is constant, but observe the boy. Here every time the boy's direction is being changed. Okay, that means velocity is being changed. As velocity is being changed, acceleration exists. One more example I am showing you, my dear children. See the car traveling around a circular path, in a circular path. Observe the car, how it is moving every time. Actually here you can observe the speed is constant. What about the direction? At every time the direction is being changed. Okay, now my dear that means velocity changes. When direction changes, velocity changes. Now we will see, actually, my dear children, the formula of velocity, that is distance by distance or displacement. As it is circular motion, there is no displacement, you know, I already explained to you. Only distance we will consider, distance by time taken. Okay, now what is the distance that is traveled in a circular path? So in a circular path, displacement is 0 whenever it is moving one complete circle. What about the distance? Whenever it is starting at a particular pointing and reaching to the same point. That means it completed one circular round. What is the distance? Perimeter of circle, that is 2 pi r by time taken t. Okay, what is the distance? Perimeter of circle, 2 pi r by time taken is t. Here the velocity is actually a tangent to a particular point. How the velocity vector? It is tangent to the particular point. And how the acceleration acting? Blue color I am showing you. It acting downwards direction, downward in the sense to the center of the circle. As it is acting towards the center of the circle, we say centripetal acceleration. Okay, whenever acceleration acting towards the center, or the direction of acceleration is towards the center, whenever the direction of circle is acceleration is towards the center, we say centripetal acceleration. Okay, summary we will see, my dear children. Uniform circular motion is a accelerated motion, so moving with constant acceleration. Now direction of velocity will be along the tangent. Okay, now direction of acceleration will be towards the center. Now angle between velocity and acceleration will be 90 degrees, my dear children. Okay, okay, hope you all understood, my dear children. Now we will see, that is equations of motion. In that we will see first equation of motion. Okay, what is the first equation of motion? In order to derive the first equation of motion, that is v equal to u plus at, v equal to u plus at, that is v is the final velocity, u is the initial velocity, a is the acceleration, t is the time taken. The first equation is v equal to u plus at. Okay, v equal to u plus at. In order to derive this, we need acceleration. We have to know acceleration. You know what is acceleration? Till now we have seen acceleration. So acceleration's vt graph, that is velocity time graph, you need to know, my dear children. Acceleration is equal to rate of change of velocity with respect to time. So you have to draw the graph for those two things. You have to draw the vt graph for the acceleration, and slope of that vt graph will give you the first equation, that is v equal to u plus at. See here, initially the velocity is u. Okay, when the body is at a point a, and finally the body reached to, after t seconds, the body reached to the point b. At point b, the velocity is v, that is final velocity. Initial velocity is 0, not 0, we will say some. Okay, here we will represent it as u, and the final velocity is represented as v. So from the graph, vt graph, we have to derive the slope, my dear children. So what is slope actually? y2 minus, simple formula I am telling you, y by x, that is y2 minus y1 by x2 minus x1 we will write. So where is y-axis? Velocity. What is x-axis? Time we have taken. So y coordinates or y points. See here, what is y points? Final point b. Okay, so we have to write y coordinates or y points, we have to write, my dear children. Simply y2, that is be minus v minus u by, what is y2? V. Y1 is u. So bd, that length you have to write. Okay, bd minus bd by ad. Okay, here you will write bd by ad. So similarly you have to take represent on y coordinates, that is v minus u by Okay, y points you have to represent, my dear children. Here I am not I am showing you, but I am not reading every point. I am telling you the simple formula, that is y2 points v minus u by oe. Okay, what is oe v? What is oa u? Okay, what is oc t? Okay, now so y by x, that is y coordinates by x coordinates, you have to write. What are the y coordinates? v minus u by t. So from the acceleration formula, v minus u by t, so from that we will derive final velocity v minus u equal to a into t. So bring this t towards the left hand side. So what you will get? V minus u equal to at. Now take the u to the right hand side. Finally what you will get? V equal to u plus at. So this is the first equation of motion, my dear children. In this video I already showed you equations of motion. So in that, one among the equation, that is first equation, is v equal to u plus at. Here v is final velocity, u is the initial velocity, a is the acceleration, t is the time taken. Okay, using these equations we will solve problems. Okay, there are two more equations. Okay, now my dear children, hope you all understood well. Thank you. Children, I hope you understood till now what we learned. Okay, in the next session we'll solve some problems, thereby our topic will be completed. Thank you.